Alright, boys and girls, welcome back to the drive-through for a little 7-1 to 7-3 pre-quiz help video. I was going over Haruno's quiz with her and realized that I kind of failed to prepare her for this couple questions. So, we're just going to get right into it. The first thing we're going to deal with is this continuous growth, or investments that are compounded continuously. Unfortunately, I don't have enough time, and you guys don't have enough understanding of limits yet for me to fully explain this concept to you. But essentially, you could understand that it would be to your benefit, instead of just getting your interest to compound annually, to get it to compound quarterly. And it would also be to your benefit, instead of getting your interest to compound quarterly, to get it to compound monthly. And it would be to your advantage to get it to compound daily. Well, what if we could get it to compound hourly? What if we could get it to compound every minute? Well, as it turns out, there is like a limit to how much advantage that gives you. And even if your investment compounds continuously, so like every instance it compounds on itself, that still won't make you like a super billionaire. There's a limit to how much that compounding can help you, and that limit helps us find this really important number in math. It's called E, and E is similar, I'll just use bad math, it's kind of like pi, meaning it is a number. It doesn't change. Although E can be used with some logs to do some really nice thing. E also has a very important principle in calculus where its derivatives is also equal to itself. But E is just a number. And when you have continuous growth, you've got this investment equals PERT. And what this stands for is principal, so that's how much money you put in, times E, this is just a number, times, this is your rate, and it's your rate as a decimal. So 5% would not be 1.05, it would be 0.05, okay? And then this is how much time you're going to let your investment sit still, okay? So Tori is investing $1,200, let's say it's $1,200. It's bad math that I didn't put a unit. And she's going to get it to compound continuously for 4 years at a rate of 7%. How much cash, there we go, will Tori have when she removes her investment in 4 years? Let me get my calculator pulled up. Okay, so our investment will be our $1,200 initial investment, which is called principal in this chapter, times E to the 0.05 times 4. So all we got to do is put this in our calculator right. So 1,200 times, where's our E at? There it is. It's above ln. That's a good spot for it. E to the 0.05 times 4. I typed that in right. You might have to hit over, like, just so you get used to that if you have to do other operations. What do we got? $1,465.68. All right, so that's how you do those. All right, now this is an application for this that is basically chemistry based, and it's about half-life. All you need to do is understand what half-life means. Shout out to Ms. Villardo and Mr. Arnold. I can't remember who I asked about this, but they confirmed that half-life just means how long it takes for half of this element to be gone. So like this is important with like uranium or really like I guess toxic stuff. They want to keep track of how long it takes to go away. You can even probably figure out the half-life of plastic. Okay? So we've got quaternium is the element of the future, element number 151. And quaternium has a half-life of 144 hours. The initial amount of quaternium is found to have a mass of 1,000 kilograms. What is the exponential function that goes with the situation? Well, here's the half-life function. Okay? The half-life function kind of looks like exponential growth. Okay? It's b times r, but instead of it being b times r to the x, it's b times r to the x over half-life. Okay, so let's just put this in, and I think it'll make sense. So, in this case, it'll be b, f of x is b times r to the x over 144. Okay? Where b is still the y-intercept, so our initial... Come on, ViewSonic. Initial amount. Sorry about the handwriting. And R. Let's see. Is our rate. And then X in this case is our time. So in this case, it's in hours. So let's set this up and see if it makes sense. F of x will be 1,000 times r to the x over 144. Now here is where I have to do some explaining. In this case, we're talking about half-life, okay? So we want to know, and this is just arbitrary, somebody made this up, when will half of our quaternium be left? So what we want to know is when will our rate be a half? So if you could imagine, after 144 hours, we would plug in a 144 in for x, and that's going to be 1,000 times 1/2 to the 1 power. Oh, that makes sense. After 144 hours, if you plug it in, which I will for you, we're going to have 500 kilograms left. So let me show you that. If we typed in y equals 1,000 times 0.5 to the, and then x divided by 144. Okay? Let's look at the table. Okay, you can see that it is decreasing. And if we just jump ahead, it's decreasing slowly, as you know, decay often does. If we jump ahead, if we go to table settings, and if we start at 144 and look at what happens, boom, there you can see. We've gotten to 500 kilograms after 144 hours. Okay? So let me clean this up. But hopefully you see that's why the half-life equation is what it is. In the half-life, the rate will always be 1/2. If you wanted something called a quarter life, then the rate would be 1/4. Okay, but in this class, we're just going to deal with half-lives. So now let's look at the question. What is the exponential function that goes with this situation? That would be this. That's our function. All right, how much Conernanium will be left after 128 hours. All right, we can do that. In fact, let's just go right back to our calculator. We're at 144. Let's just scroll up to 128. And there you go. 540.03 kilograms. Oops. Okay, and that is essentially what F of 128 equals. So that should help you on your first Chapter 7 quiz. Good morning, Tori. Boom!